Good morning, students. Welcome to fourth semester Environmental Studies. So, we are going to start this class from a topic radioactive fallouts and its effects on environment and human health. So, let's start our topic. First of all, what is radioactive fallouts? Deposition of radioactive particles released into the atmosphere from nuclear explosions or leak from nuclear installations and power stations on the Earth's surface is known as radioactive fallouts. Radioactive fragments and isotopes of other elements activated by the radiation of the explosion as well as the radioactive offsprings of these isotope fragments. What is isotope? Isotope is the different morph of a chemical or an element. They have different atomic mass and they have different physical properties, but they behave similarly. The contaminated water droplets that are in the atmosphere inhaled or reach the ground, they contaminate our crops, wildlife, and our drinking water. If cattle graze in such an area which is being exposed with these radioactive fallouts, their milk can be contaminated. The earth may be contaminated for decades and possibly for the centuries. And by this process, it causes the radioactive rains. This phenomena has been observed since the period of large-scale atmospheric nuclear testing occurs in 1950s and in early 1960s. And after the signing the treaty and the test limitation treaty in 1963, levels of radioactive fallouts have been decreased worldwide. Weather conditions have a major influence on radioactive fallouts, particularly the local rainfall. Atmospheric winds are capable of carrying the precipitations of radioactive particles to the large areas. The individual radioactive particles are invisible. They are so light that they can spin and spin in the atmosphere around the planet, whereas the heavier particles and the larger particles, they fall down earlier on our Earth's surface. When a nuclear weapon is exploded near the Earth's surface, the violence of the explosion crushed and make a vast amount of material. Here you can see a mushroom-like formation of the nuclear blast, much of which is absorbed into the fireball here, the upper part, and hot mass that rises from the characteristic mushroom clouds. The radioactive particles adhere to heavier particles which act as a blast, to which we used to call a mushroom-like blast. Particles of smaller but easily visible mass carried out by the wind fall to the Earth's surface after several hours and are called as local radioactive fallouts. The nature and extent of the explosions depends on the type of the strength of the explosion, altitude of explosion, and the speed and direction of the wind. Macroscopic particles remain suspended for a longer period in our atmosphere, whereas the heavier particles, they fall down earlier on our Earth's surface. In such cases, the so-called trophic fallout occurs, and the bomb fragments move around the Earth following the latitude where the explosion occurred. Radioactive rain can cause different effects. That is, the actual fallout pattern depends on the radioactive fallouts. On wind speed and direction of the terrain, radioactive fallouts depends on it. Largest particles definitely will fall out earlier on the ground zero, and the small particles, they spin and spin again and again around our atmospheric conditions and around our planets. The figure shown here you can understand the fallouts of the radioactive. The incoming solar radiations which comes out from our after the explosions, out of them 47% they come out to the earth, fewer reaches directly to the earth's surface, 25% are being scattered down, and 5% are being absorbed by the dust particles, whereas 14% absorbed by the atmospheric and they remain in our atmosphere in the form of molecules in the dust, and 3% are being absorbed by the clouds, and out of them 22% radiations diffuse out to our Earth's surface, then they can contaminate our atmosphere and our earth and our crops, our vegetables, our vegetations, or they can harm the human beings also. So that is the pattern of that how the radioactive fallouts contaminate our Earth's surface. Now, what are the biological effects they cause to the humanity? The radioactive fallouts, basically the radiations, they affects our DNA molecules that is found in our cells, and they damage the DNA molecules, or you may call they cause the mutations. And after the mutation, the cell may be the malignant. It can cause the cancer, or it can cause the tumor. Radiation can damage our DNA molecules in two ways. It may be direct or it may be indirect. So in direct way, it directly releases the electron molecules from the DNA molecules. Hence, a mutation occurs in the DNA molecules which cause harms to the human bodies. And the indirect way, simply the radiations or the radioactive molecules, they activate the water molecules in presence of the radon, and they release out one electron molecules and they form the hydrogen ions, that is H3O. And this H3O, they replace the hydroxyl molecules from the DNA molecules, and which is an indirect effect on the DNA molecules or the genetic materials of the human beings, which later on cause mutations, and it may be changed into malignancy or the tumor cells. Now, here again you can understand the effect of these radiations. If we divide the radiation, there are the various types of waves: alpha, beta, neutron, and gamma. Here you can see the alpha can cross the paper through the paper, beta through the human body, as well as through the metal it can cross, and neutron it can cross to the human body, paper, metal, and it can reach up to the water level. But it cannot touch or it cannot cross the concretes. And if the radiations are gamma type, then they are very dangerous and very harmful. They can penetrate the whole metals, paper, human body, water molecules, concretes, and even cements, wooden, whatever it is, they can cross out as well. That is a very harmful radiations that is cause the mutations in the human body. Now, another pathway of the causing the biological effects by the radioactive substances. Here you can understand, here is the uranium-238. It converts into the radium-226 and then radium-222. Because uranium as such cannot penetrate through the Earth's surface, it divides, it converts into the radium-226 and radium-222, and it enters into the our Earth's surface, and from Earth's surface it enters into the bedrocks of the soil, and it can enter through the water channel in our houses. And from here houses, the water we drink or we take bath in such radioactive water, that can penetrate in our body, and definitely it will cause a damage to the DNA molecules of the human body. Now, what effect it cause on our food? The surface of the fruits and vegetables or food of animal origin can become radioactive if airborne or airborne materials are being deposited on such food materials, that is being radioactive food materials. Food can also become radioactive as a radionuclides pass from the soil to the crops and animals. So you can understand they are how harmful they are. They can enter through the soil also. If the radioactive substances being deposited in the soil bedrocks, then through the water channel they can enter into the crop, in our crops also. And such crops are always be a radioactive crops. So radioactivity cannot contaminate the canned foods. So we should always protect our foods into the plastic wares or into the canned one, because the radioactive substances, they cannot penetrate the metal. How to prevent from radioactive fallouts? First, preventive measure is vegetables and forest crops should be covered by the plastics or the tarpaulins, and we should keep our livestock under the cover. We should harvest our crop earlier than ripen if the fallout, for some fallouts occurs, and we should avoid the locally produced milk and vegetables if at that place some radioactive fallouts occurs. Now, what are these chemicals or the chemicals which are harmful for the humanity and for our own environment? So, these radioactive elements, out of them, the first one is the strontium 90. It is a very long lived with a half life of 28 years, and it is chemically similar to the calcium. It causes it usually accumulate in our body in bones, and it causes the tumors, leukemia, and other blood abnormalities. Similarly, the iodine 131 has a half life of 8.1 days, and its ingestion is very easy. It concentrates in the thyroid glands, and if it attacks our thyroid glands, then the total metabolism of a human body is being disturbed. And just to cure it, usually the potassium iodide tablets are used. That is not an antidote of the radioactive elements, but it is the cure to protect our body if the thyroid gland is being exposed by the radioactive fallouts. The another one is tritium. It is released half-life is 12.3 years, and it can easily be ingested since it is replaced as a hydrogen in the water molecules. And the beta radiation can cause lung cancer. Lung are our the live organs. They are the very early they are being affected. Cesium 137 has a half-life of 30 years. It does not present as a large biological threat as a strontium. This can contribute to gonadal irritations and genetic damage. It causes the infertility in the human beings. Plutonium 239 has a half-life of 24 to 400 years. Ingestion of as a little of 1 μg of plutonium is barely visible, or you may say barely visible as speck of this plutonium. It can cause the bone or the lung tumors or the lung cancers. So it's very harmful. Here I have given few units of the radiation, that how we measure it and what is the purpose of their measurement. So usually we measure it in the form of Curie, Gray, and red, and the Rami. Here you can see the radiations, that how they are being measured. The another important factor of this radioactive fallout is the ozone depletion of our environment. How it depletes. When a nuclear weapon explodes in the air, the surrounding air is subjected to a great heat and followed by relatively very rapid cooling. These conditions are ideal for the production of tremendous amounts of nitric oxide. And these oxides are carried out into the upper atmosphere. They reduce the concentration of our protective ozone layer. And this nitric oxide produced by the weapons allow more ultraviolet radiation to reach our environment through the atmosphere surface on the earth. And definitely you know that these radiations are very harmful for the human body, for our crops, for our vegetations, for our livestock. So it has been estimated that as much 5,000 tons of nitric oxide that is being present in the explosion or the nuclear explosion is produced for each megaton of nuclear explosive power. So you can understand by this word the hazardous effects of the nuclear weapons and the radioactive fallouts. If such explosions occurs in our atmosphere or on the globe, then how it is being harmful for the humanity and for all the living beings. So just think about it. Thank you. That's all about the radioactive fallouts.